Join the State 16 community webinar, live on Zoom, July 22 at 20x Israel time. Explore robotics, embodied intelligence, guardrails, open robotics ecosystems, and production-grade physical AI with leading experts.
So Ori, you can share the screen, and meanwhile, I will say a word or two even about Ori, which I really like him. He's one of the best Israeli contributor, I think, in the world of the robotics. So Ori is a data and AI senior staff engineer. He focuses mostly on the agentic development, the AGI, the robotics and LLM-based workflow at scale topics, and he's the creator of Culture.dev. And Ori, I think that the stage is yours right now, and so I will let you present. Let's see if you can hear you.
Hey everyone, can you hear me?
Yes.
Thank you for coming. I'm Ori Nachum. I work at Tipalti as an AI expert, senior staff engineer, and at my free time, I'm not resting. I'm sharing and developing open source. I lead a couple of communities, AWS Gen AI and NVIDIA Jetson AI Lab. It's an open community, both with NVIDIA and Amazon support. And I'm happy to share that I'm the first Israeli who holds a Richie Mini and connected it to the Jetson Tor. And I want to share with you, after a long experience with working with robots, thank you, Steven, working with robots and sharing some of my experience from working with agents in the non-physical world, with different applications, a different way to control and operate robots. So let's start. Today, we want to have smart robots, and we do that with we have different tools for that. We have code that we write, which may be a little rigid. We have models that we train to put intelligence on the machine or abroad, and we do some agent connect it as agent tools, maybe as an MCP that some harness can connect and control the robot. And we use all of these methods to have smart robots that can see the world and operate. And it's really exciting to see that Le Robot arm, teaching it with the leader and follower arm, move objects from one place to another. And it's hard and it's super interesting. I want to share my approach that is a little different. Not better, not worse, just different, and maybe using that and others makes robots more accessible and smart, but still safe with human gates to control their freedom. The idea is like this. I separate the control of the agents, of the robots, from the agents to a layer, CLI, which is actually, it's a console app or a package. And that package controls the robot, but also controls, it can give it the actions or ad hoc commands, but also control the behavior of the robot. It means that it controls the senses, the rules, and all the conditions that we want the robot to behave, to act, right? So if I have that robot that sees around and sees children, for example, and I want it to be careful, I could have an agent tell it, be careful, and if you notice, don't walk on them, but we all know that it's very scary. Instead, we can give an agent the ability to define the behavior. So instead of an agent trying all the time see that there is no animal or children or a person, a big person on the way, we can have it control the behavior, the rule. Look around. If you have check your sensors, all that in code. But instead of being a rigid code, as I mentioned earlier, this time we have an agent that controls the runtime that oversees the behavior all the time. And that gives us two things. The first is a runtime that a runtime where the robot sees all the time and reacts immediately. It's not dependent on some model that may take some time to think and act, but also a robot that can react and invent new things because there is an agent that sees all the issues all the time and can make decisions, and on some cases send to a human to approve that new patch or new behavior that it wants to add. Like it does a little pull request for itself, where it now codes for itself a new behavior. It's sort of like what Anthropic did with their experiments of Minecraft and their agents that run around and have strategies of how they exist in the virtual world. In this case, this is the physical world. So it's really effective giving the agents that level of maneuverability. It has a lot of benefits. Excuse me? Sorry. It has a lot of benefits. It means that when an agent, as I said, is stuck in a new situation, there is if the robot is stuck in a new situation, there is the agent that oversees and can code a new behavior or make existing behavior more complex or more flexible to overcome that obstacle. It means that if the robot is now is disconnected, because we know that internet is not reliable and not always we can have a strong model, a strong edge device like Jetson on the robots, and we want to give it something smaller like the Nano maybe, or Raspberry Pi to handle the smaller difficulties that it may experience. It means that the robot is always on. We are not reliable. We don't rely anymore on internet, and because it has that subroutine that acts all the time, I use 50 hertz and queue actions all the time to have it stay alive. Let's see, no, stay alive, and that lets the robot stay act and behave even if it doesn't have an internet. Fun fact, I took one of my Riches, the wireless, to work. It didn't have AI, and people still loved it because it was so cute and kept moving, and it felt so alive without any AI. And you can also pet it, which is super cool. What I work on now are two CLIs, two ways to control the robots. One for Richie Mini that I really love. I have two. And I use it to give it some feeling of liveness for children, for a family, like a friend that I can talk with. And when I know, because it happened to me in the past, when I reach some place without internet, I know it will keep and will stay alive even then. And the next one that I have already started is the robot arm, which I really like. It's really a level upper. I probably don't need to tell you about it. Where I have stronger control on the motors, and then I use the arm to give it some boundaries, what I feel is okay. And using agents, I can talk with the robot and have it examine itself and explore its surrounding by itself and give me the result. And then I turn that into deterministic boundaries that I can rely on, even when even if the AI one day hallucinates. I know that the robot will stay safe because that's how I lock its behavior. What I do next is give it more senses, memory, because I really wanted to go to places in my hands, participate in webinars like this one, and people have it, see it, and interact with it. And it goes for both robots. It goes for Ichi Mini because it's super cute, and it goes for the arm robot, because it can really interact with the environment, and pick up stuff, maybe put both of them under the same agent to have Richie being able to pick up stuff himself, because Richie is actually the agent that controls it. Both projects are open source. You're all welcomed. It's under Agent Culture organization on GitHub, and we'll share them later. Both robots are also accessible. You can check them out. This whole presentation at agentculture.org. Thank you very much.
Wow, thanks. So it was really interesting, and I will be glad if someone want to ask any question on the chat. Please do it on the chat. And let's see if we can get some question here. But it was really curious and encouraging. And I want personally to ask, what should a robot never be allowed to rewrite? But only if you want to.
Again, what's the question?
What should a robot never be allowed to rewrite?
So it probably shouldn't be allowed to rewrite its own controls, right? But if you gate it with, don't let it rewrite control its gates, and then put your gates. Sorry, my little daughter is curious about here. And put these gates protected. Everything else is on you and us to make sure it doesn't breach its own boundaries.
Yeah.
Right.
Yeah, actually, yeah. I see there are two questions, so I will read the question by Nadav. Do you envision robots to interact with sound, speech? This is cool.
Yeah, so I solved it in my way in giving robots, or when I don't have text-to-speech models, I have a project called Harmonics, where a robot gets the voice based on text, but in some harmonic way. It's a little alien, but it translates to English one-to-one. So it kind of reminds me of R2-D2 from Star Wars. And then it makes sense to me that robots will have that solution, so they can talk and have this cacophony of sounds, while we humans don't have to listen to all their noise, because it's really hard for us cognitively to hear all the time speech. So it's an experiment, but it's really interesting. And but I think that they should have speech, talk to each other in voices, because sometimes they need to interact with the world like us humans to be able to do something together.
Yeah.
It's something that we need.
Okay, I will check. I see that there is only one question here by Jonathan, and then we will move on to Mike that can start share the presentation. So Jonathan asks, what are the optional interfaces between agent to robot you have deployed, plan to do?
So I wrote, I think, the first Richie Mini MCP, but today I moved to Richie Mini CLI and ARM CLI, because either as CLI or as a package, an importable package for other applications, because I think it's much more efficient. That's the interfaces that I use. I think enough. Right?
Okay.
Thank you.
Ori, it was really, really interesting. I'm really glad that we have you here. And thanks for joining us at this late hour in this country, in your country. So really appreciate it. And I